All right, we're in section 4.2 where we are applying congruence in triangles. Congruent figures come in all different shapes, but they do have a common definition. Congruent figures, all the parts of one figure are exactly the same size and shape to the corresponding parts of another figure. Now, the most basic congruent figure we have is a triangle. So we have a triangle. We have two triangles set before us, and it says up top that triangle ABC is congruent to triangle XYZ. Now, that is what is called a congruent statement. And what we have to do is we have to be able to identify from that congruent statement what our corresponding angles and what our corresponding sides actually are. And it's pretty simple to decode that because it comes from the congruent statement itself. The first one is corresponding angles. The corresponding angles come from the names of each of the vertices, and the order in which they're placed is which one corresponds with one another. So the first one is angle A, and the first one in the second triangle is angle X. So since they're both first in the naming, I can say that angle A will be congruent to angle X. And the next one would be the second letter, which would be B, and also Y. So then I can say that angle B is congruent to angle Y. And then finally, looking at the third letter in the naming, I got angle C is congruent to angle Z. Now, looking at the corresponding sides, we still are going to use the name of the triangle to help us solve that. So first off, I got a triangle AB, and AB is the first and second letter in the naming of our congruent statement. So the first and second letter in our second triangle must be congruent as well, which means they're the corresponding sides. So that means that AB is congruent to XY. Looking at the next one, I have BC here. BC in the naming is the second and third letter in my statement. So the second and third letter in the second one would be YZ. So that means that BC is congruent to YZ. And then finally, I have AC and XZ here. So AC is congruent to XZ. All right, because it was the first and last in both of the corresponding figures. So that is how you identify the corresponding angles and corresponding sides of a congruent statement. From there, we have some other theorems that we can take a look at. One deals with its angle measures, and the theorem is called the third angles theorem, which says that if two angles are congruent to two angles of another triangle, then the third angles are also congruent, which makes sense because in previous sections in chapter 4 we talked about the triangle sum theorem. If you added up all the interior angles of a triangle, it would give you 180 degrees. So if we knew A and we knew B and D and E respectively, they were congruent, we could say that angle C and angle F would also be congruent because, that also comes from the triangle sum theorem. So they just given you another name to help you out and another way to solve it. The other type of property that we're going to look at is what is called the reflexive property of congruent triangles. This is when we have a side that is shared between the two triangles. So in this particular instance, we see that they're saying that if triangle ABC is congruent to triangle CDA, we can come to the conclusion that AC equals AC. All right, the same side equals this to the same side. So that comes from the reflexive property. And now, with those things being said, we can use those three things and on top of what we've learned in previous sections in order to solve problems not only in these examples but in our homework. This example here, they're asking us to find angle BDC. So let's just make a little line to kind of help us out. So that red line is BDC. So what I have here is some things to kind of help me out. First off, angle A is congruent to angle B because of the tick marks that they're identified. And angle A is telling us that it's 45 degrees. So I'm going to write a little 45 degrees to help me out. Also, I see a tick mark with like the lower half of angle D, so it'd be like CDN is congruent to DCN, and that is 30 degrees also. So if I were to kind of draw this out, I would have triangle looks like this. I got C, D, B, and I got this little line here, so I know that this is 30, this is 30, and this is 45. I don't know what this is, so I'm just going to call it X. So X represents this angle, but that's not what we're looking for. What they want is this angle here. So since we looked at corresponding angles to help us find some other angles, we now can use the triangle sum theorem from early on in chapter 4 to help us figure out what the value of x is going to be. And the value of x is going to be 30 plus 45 plus the sum of 30 plus x is going to equal 180 degrees. So I can combine some like terms here. So I got 30 plus 45 plus 30, which gives me 105 plus x equals 180. Subtracting 180 minus 105 gives me x equals 75. But that's not what they're looking for. What they're looking for is the sum of this angle here. So all I have to do is take 30 plus x, which is 75. So 30 plus 75 equals 105 degrees. Okay? Here they want us to find the angles of x and y. This is for this example here and this example here. So, but let's take a look at this, these two triangles first. Okay. So right off the bat, I see that I have a tick mark here and a tick mark here. So those two angles are congruent. So I can write down 12x plus 4y and set it equal to 40 because they're going to be 40. Also, I know that this is 90 degrees also because those two angles make a linear pair, and a linear pair, their sums are 180 degrees, and if one is 90, 180 minus 90 is also 90. So I know that this is 40. I know that that's 90. I can use the triangle sum theorem to help me out because the sum of the left triangle is also going to be 180 degrees. So 180 minus 50 minus 90, oh, I'm sorry, my mistake. 180 minus 40 minus 90 gives me, this one's actually 50 degrees. My apologies. I kind of went ahead. So with that being said, I can now write another equation by saying 17x minus y equals 50. All right. Now you're asking yourself, well, I really can't solve that because I have the two unknowns, x and y. Well, you're right. But we do have two equations, so this now creates a system. Now, you kind of have to go back to what we learned in algebra, where we can use either the elimination method or the substitution method to help to solve that. I choose to use the elimination method in this particular instance. So in order for me to eliminate one of the variables, I am going to multiply the entire the bottom equation there by 4, which then it'll eliminate, it'll eliminate y. So what I'm going to do is I'm going to rewrite the top equation. I'm not going to change anything with that. But I'm going to multiply everything on the bottom by 4. So 17 times by 4 gives me 68. So I got 68x. I got minus 4y. And it's going to be set equal to 4 times 50, which is 200. All right, since they're opposite coefficients of each other, those now cancel. So then I can add up the like terms. So 12 plus 68 gives me, this is 80x, and this equals 240. Now 240 divided by 80 gives me x equals 3. Now all we have to do is plug 3 into one of the two equations. I'm going to choose this one here, mainly because y has a coefficient that's -1. It just seems easier to me. You can use the other one. It's not a big deal. So I'm just going to take 17, multiply it by 3 now, not x, minus y equals 50. 17 times it by 3 gives me 51, minus y equals 50. If I subtracted 51 from both sides, I would get negative y equals a -1. And then if you were to multiply or divide both sides by -1, this becomes positive, and so does this. So y is 1 and x equals 3. Looking at the second example, let me get some room. Again, we have unknowns of x and y, but we have a statement. The statement says that DEFG is congruent to SPQR. All right, it's a four-sided figure. It's a quadrilateral of some kind. And what this means is, first thing that I look at is, okay, if they're congruent, that means they have corresponding angles. So first off, I look at angle D. Angle D is 102 degrees. The corresponding angle to that would be S, so that means S is 102 degrees. Right off the bat, I look at F. F is what, the third, and that means that the third one, the next one's Q, so that means this one equals 68 degrees. So that kind of helps us. So I'm going to write down 6y plus x equals 68 because of the corresponding angles. So because it's two variables, it really doesn't help us quite yet. Anything else with, well, G and R are corresponding angles, so I'm just going to write down 84 here. But that doesn't really help us at this time. So looking at the other unknown, which is 2x minus 4, that is the side length of QR. So Q is the third letter and R is the fourth letter. So the third and fourth letter in the other one is F and G. So that means that, and they give us a numerical value, which is 12 feet. So I can now write 12x minus 4 equals 12. So if I added 4 to both sides, I get 2x equals 16. And dividing both sides by 2, x equals 8. All right, that was fairly simple because it was just one variable in the equation. I could solve for that. Now, in order to solve for y, I now know that x is 8. So I can say that 6y plus 8 equals 68. Subtract 8 from both sides, so I get 6y equals 60. And then dividing both sides by 6, y equals 10. So x is 8, y is 10. And that is being able to apply the congruency and triangles. Hope this helps. Until next time.